Today we're going to talk about derivatives of logs and exponentials. So exponential functions will look like this, or a function, a constant raised to a power. Log functions will look like this, or log of a different base. Remember, natural log of x, that's the same thing as log base e of x. The basic formulas you're going to initially memorize are those of derivative of e to the x and derivative of natural log of x. Derivative of e to the x will be itself. So this one is very straightforward. Derivative of natural log of x is 1 over x. A little less straightforward. Now from these we can derive the formulas of the derivative of a to the x and log base a of x using log properties. I'm not necessarily going to go into that today, but basically if you were to rewrite a as e to the natural log of a to the x and then use chain rule, you'll end up with the formula. But the derivative of a to the x will be itself, much like this, but there's going to be multiplied an extra factor of natural log of a. Derivative of log base x will be 1 over x, but now we're going to multiply on the bottom an extra factor of natural log of a. So note that in both of these cases we have a factor of natural log of a. For the derivative of an exponential, it remains on top. For the derivative of log, it joins the x on the bottom. So as an example, if I have 5 to the x, the derivative is 5 to the x natural log of 5. Note that this is not chain rule. This is just part of the basic formula. And so if you have a problem that will require chain rule, if I have something y equals 3 to the 4x squared, you need to treat your exponents as a set of parentheses. So if that includes something that is more complicated than simply x, chain rule applies. So our outside function is 3 to the something, and our inside function is a 4x squared. So applying chain rule, the derivative of 3 to the something is itself times natural log of 3. Remember, this whole thing is part of the derivative of the outer function. Do not write this and think, okay, you're done because you wrote something extra. You still haven't done the chain rule part. So now we multiply by the derivative of the inside. Derivative of 4x squared is 8x. And again, we can simplify a little bit by bringing stuff into the front. It doesn't really matter that much in this case. Now, when we take the derivatives of logs, it's going to actually be beneficial for us to make use of log properties. Remember that if you have a log of a product, you can write it as the sum of two logs. If you have the log of a quotient, you can write it as the difference of two logs. If you have a log of something raised to a power, you can bring that power in front. All of these things will be very helpful as far as taking the derivatives of logs, because you want to simplify it before taking the derivative. For example, if I have something like y equals natural log of 4x squared sine x, I could take the derivative the ordinary way. So using chain rule, my outer function is natural log of stuff. My inner function is this product. So the derivative of natural log of stuff is 1 over stuff. And then now I have to multiply by the derivative of the stuff, which itself involves product rule. So if I do the derivative of the first times the second plus first times the derivative of second, I end up with this. However, it might have been easier to go ahead and use log properties. I have log of 4 times x squared times sine x, so I can write that as log of 4, natural log of 4, plus natural log of x squared, plus natural log of sine x. I could further use log properties to bring this out in front. And notice that I continue to write y equals to avoid confusing myself and thinking I've taken the derivative already. As long as I keep writing y equals, I remember, okay, I still have to take the derivative. Now I'm ready to take the derivative. Derivative of a constant is 0. 2 times ln x, so derivative of ln x is 1 over x. And then derivative of natural log of sine x, I'm going to go ahead and use chain rule here. So it's going to be the bottom. It's going to go into the bottom. And then I multiply the derivative of sine x, which is cosine x. Cosine over sine can be written as cotangent. So although this specific problem involved writing more lines, the chances of error are lower because I was able to simplify this such that at any given stage when I took the derivative, it was either the basic derivative or it was a one-step chain rule derivative, rather than potentially screwing up the product rule here. So highly recommend that you use log properties to simplify as much as possible before taking the derivatives.